Good Thursday afternoon, everyone. Welcome to Lecture 7, Maths for Construction. If we go on the homepage here for Notion, we would say I added a section, textbook chapters to study, right? So here, we use an engineering mathematics, right? By John Bird. This is how it looks like, right? 5th edition, right? We have a table of contents here. And what I did is I outlined all the chapters that you all need to focus on. Okay, I numbered them and I tell you the sections that you need to focus on, right? So for your algebra foundations, you're doing these chapters here 1, 2, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15. Try to do all the problems in these chapters as well. You all need to self-study, right? Because we don't really have enough time to go through all of this. If your background is kind of weak, probably had to work a little hard and send me questions and answers for extra help, right? Now you could do this in any other one, but we started the algebra. We're doing the algebra section first, right? We want to move on to geometry and trigonometry and graphs at some point, right? So these are the chapters here for that. The chapter is very short, you know, even though it is a lot of them. Like this chapter here, chapter 1, you know, it's literally 6 pages. 1, 2, 3, 4, 5, 6. Some problems under it, right? The chapters is be very short. They don't be very long, right? Like look at the algebra chapter here, 1, 2, 3, 4, 5, 6, 7, 8, 9 pages, right? To do these questions here. So the chapters are not long. They're kind of short. They could do one every day, every other day, that kind of thing. You'll need to work really hard for this course, right? There's a lot of math we need to cover. As we say, we have the course outline, right? Course outline has things like, if you scroll along here, I have matrices, it have statistics, it have algebra, it have trigonometry, it have more statistics, distributions, right? Calculus, arithmetic progressions, I mentioned analysis, vectors, right? Vectors again, right? So essentially, I split it up here. See the graphs. This is the statistics that you had to do. You might have to do some extra statistics that the book doesn't cover. This is the calculus here. These vectors and these matrices, okay? So I gave you all an idea what these sections are. So just start from the beginning, chapter 1, and keep going, okay? Do all the problems, check the answers at the back of the book. And when you don't understand something, you have to reach out to me, okay? Okay, so the actual homepage for the course itself, we say I put up some new worksheets here for you, right? So you could try them out. We have difference of two squares and factorization, partial factorization, right? These are things that you should be able to do fairly quickly. We continuing with lecture 7 today, where we start talking about something new. What it is we want to talk about today. The idea of actually, you know, solving equations, essentially, solving equations. So expressions, right? We want to talk about order of operations. So when we look at an expression with one unknown variable, can we determine the steps needed to evaluate the expression when we substitute a value for the unknown variable, okay? So given this expression here, 2x minus 5, what is the value of the expression if x has a value of 3? what would the value of the entire expression be? Okay. So BODMAS applies here. You know, we have an expression 2x minus 5. X has been multiplied by 2, and then the 5 is being subtracted. But if x is 3, what is the value of the expression? The value is determined by BODMAS. We do multiplication before subtraction. So it's 2 by 3, which is 6, minus 5. So the value of this will be 1. You're not going to take away 5 from 3, right? You're not going to say 3 minus 5 is minus 2, and minus 2 by 2 is minus 4. That's not the correct order, okay? So expressions are evaluated based on a particular order, okay? Now we could write an expression for this here. Well, we could write something like a flow chart, okay? Not so much a flow chart, but we would like to call a sequence diagram. Okay, so if I start with 3, what do I need to do? All right, what do I need to do to substitute? So I need to multiply by 2. To get 6, right? And then once I get 6, I need to subtract 5. When I do that, I will get 1. Okay, so this is a sequence diagram here that tells you the order of operations, right? So from 3, multiply by 2 to get 6, and then you subtract 5 to get 1. We can represent this in terms of the variable x, right? We start with x and we multiply by 2. What will we get? We get 2x. And then when we subtract 5, we get the expression 2x minus 5. So what we want to do is we want to look at expressions and draw sequence diagrams for them, okay? So what is the sequence diagram for this expression here? 3x squared minus 7, okay? Look at how I did it here. Start with x and draw a sequence diagram to arrive at the final expression. Okay, so let me duplicate this here. All right, if we start with x, what do we want to end up with? What we want to end up is the actual expression, right? So we're gonna have some unknown things here, and we're gonna have some unknown intermediate results, right? And we may actually have more than one. So if I have x, the first thing I need to do to it, the first operation you do to x is you square it, okay? If it's squared, you'll get x squared, okay? Remember we had into 3x squared minus 7. Then we need to multiply it by 3. So multiply x squared by 3, you get 3x squared, okay? And then finally, what we need to do is subtract 7, okay? Some people say, well, if you start with x multiplied by 3x, that's not actually the right thing to do, because you wanna apply an operation, right? Multiplying by 3x is not an operation. Multiplying by 3 is an operation. Multiplying by x is an operation. You need to break it up a little bit smaller, okay? So the first thing you do is you square x, then you multiply by 3, then you subtract 7, okay? So this is one you could try here. It might have several steps to this. Starting with x and you want to get the expression, yeah, how would you do this? So if I had to substitute a value in here, that value has to be, if you look at the brackets, it's 3x minus 2. So I work out brackets first. So you're going to square after you deal with the 3 and the 2. But man says to do multiplication before subtraction. So I need to multiply by 3 first. I'll get 3x, okay? And I could put brackets around it. But you know, just to keep it in order, right? I need to subtract 2 after. So I got 3x minus 2. I need to square after that. And then finally, to get the final term, just need to add 4, okay? So this is how you would do that, right? Now, why are we doing this? Why are we doing this? What could you use this for? What I want you to show is we need to find a reverse sequence diagram, right? So first of all, let's talk about reversals. Okay, operation reversals. So operation reversals. If we add 5 to x, how could you undo the addition? You have x and you add 5 to it, you get x plus 5. How do you go in the reverse direction? If you have x plus 5, what do you need to do to get x? You need to do the reverse of addition, right? Which is subtraction. Same thing with multiplication. If I have a number and I multiply by 3 to get 3x, how could I undo that? Undoing is not taking away 3. Undoing is dividing by 3, okay? So if I have 3x and I want to get back x, I just need to divide by 3. I have things like addition. Addition is reversal of subtraction. If I have x and I take away 7, then I'll get x minus 7. But if I have x minus 7, how do I get back x? You just do the reversal, which is add 7. So the reversal of addition is subtraction, reversal of subtraction is addition, right? Division and multiplication are reversals of each other. If you multiply by 1/5, then multiplying by 5 will undo it. Division is the same as multiplication by a fraction. Dividing by 5 is the same as multiplying by 1/5. 1/5 of something, which is to multiply by 1/5, is the same as dividing that thing by 5, okay? Reversal of square is square root. If you have x and you square it, you get x squared. How do you go back any direction? The answer is square root, okay? Not divide by x, right? Plenty of people say divide by x, but you don't know what x is. That's the point. If I ask you a square number and I get 7, what's the original number, right? You can't say, well, divide by the original number. What is the original number? You don't even know it, right? That's why the operation is called square root. There's another one as well, for more interesting, for more complicated examples, right? If I have x and I invert it, okay? If you invert x, you'll get 1/x, right? Well, if I have 1/x, I have 1/x. What should I do to get back x? Right? This might be tricky. I have x and I invert it, I get 1/x. If I have 1/x, how do I get back x? What should I do? Anybody? So the answer is the answer is invert. Okay. Reversal of an invert is an invert. Okay. If you invert 1/x, you'll get back x. I hope that makes sense though. If you invert 1/2 and you'll get 2. Right. So that's the reversal of invert is invert, right? That was like a trick question. So where we should be example 4. Right? So reverse an expression operation. If I have this expression here, 2x minus 5, and I have this sequence diagram here, the reverse sequence diagram is starting on the right with 2x minus 5. How do I get back x? So what we do, reverse the arrows. All the arrows was going left to right. Now reverse them right to left, and we replace each operation by its reversal. So the reversal of minus 5 is plus 5. The reversal of multiply by 2 is divide by 2. So this is the reverse sequence diagram. So if you have an expression, we should be able to find a reverse sequence diagram, okay? So let's do it for the question we had above, example 5. We'll do it for this guy here, right? So I want the sequence diagram and the reverse sequence diagram, okay? So this example we did a while ago, right? 3x squared minus 7. This is the sequence diagram. What is the reverse sequence diagram for this? Okay, so basically what you have to do, when you find a forward sequence diagram, just copy the diagram and change the direction of all the arrows. And above each arrow, where you would have the operation, you just want the reversal of it. So the reversal of -7 is +7, okay? Then, what is the reversal of multiply by 3? Divide by 3. So multiply by 3 reversal is divide by 3. What's the reversal of square? Reversal of square is square root. It really is that simple, okay? The hardest thing to do is to get a forward diagram. For example, 6 now, we got this forward sequence diagram from before. Now we just need to reverse it. So you copy the diagram, change your arrows, and start from the right. what is the reversal of +4? -4 is the reversal. What is the reversal of square? Square root. What is the reversal of -2? +2. And reversal of multiply by 3 is divided by 3. Yeah, the reverse sequence diagram is basically the forward sequence diagram, just the reversals of everything, okay? So given this expression here, I know as the sequence of events to get back to X, right? This is the importance of the reverse sequence diagram. Starting with the expression, I have operations I could perform to get back to X. And this is essentially how you change the subject of the formula. If you have an expression and they ask you change the subject of the formula, what you're doing is you're starting with the unknown variable and you're building up the expression that contains the unknown variable. So like this is the unknown variable, this is the expression here. The unknown variable is X. You start with X and you build up the expression that you were given. And then you do the reverse sequence diagram, and I will tell you the order of the operations you have to perform in order to change the subject of the formula, okay? So we could actually write that down, okay? So we'll talk a little bit about equations first, because that's the easiest application of this here is equations, right? So just a recap of what equations are. You have two expressions separated by equal sign. These are 4 examples of equations here. First equation is very simple, x equals 3. Both x and 3 are expressions, you know. X is a simple expression, 3 is a simple expression. The second equation, 2x minus 7, is an expression. An expression consisting of 2 unlike terms. The right-hand side is an expression consisting of 1 term, which is -3. The third equation is a much difficult expression from the first one. We have 3 unlike terms on the left-hand side, constituting 1 expression on the left-hand side. The right-hand side is again a simple expression. And then we could have the variables on both sides, as the fourth equation shows. There are 2 expressions separated by equal sign. An expression could be a single term or a number, okay? Normally, you always ask to solve equations. Most of the time, you have 1 or more unknown variables, and we need to find the value of that variable that makes the equation true. So, for example, when we have this equation here, x minus 5 equals 7. We must find the value of x such that when you subtract 5 from it, you get 7. We could guess, you know, we could think a little bit and say, well, if I have 12 and I subtract 5, I'll get 7. So the answer is 12. But we need a systematic way to solve these equations without too much thinking. And this is where the idea of transposing comes into play. Before that, let's look at changing the subject of the formula, because that is actually a fundamental thing that you need to do, okay? Changing the subject of the formula, this is one of the most important things in basic math. You can't do this, you're basically gonna crash and burn on all your topics, right? This is basic algebra. So step 1 is identify the variable 1 to make the subject of the formula. Usually they will give you some expression, right? Create a forward sequence diagram, starting with the variable and building up the expression. And then create a reverse sequence diagram from the forward sequence diagram. And then just follow the reverse sequence diagram operations and apply the operations one at a time to both sides of the equations until you have the unknown variable. So that's the kind of example one. This is solve for x in this equation. Well, what is the expression? First of all, what is the unknown variable? X. X is what we want. So where's x? X is on the left-hand side. The entire expression on the left-hand side, that is what we need to create a sequence diagram for. Starting with x, create a forward sequence diagram that ends with the entire expression on the left-hand side. What do I need to do to x? I need to subtract 5 to get x minus 5. Step 3 is just create a reverse sequence diagram of this. Starting from the expression, add 5 to get x. And then apply the steps in the reverse sequence diagram to, starting from the right. To both sides of the equation. So the original equation is x minus 5 equals 7. I need to add plus 5. So I do that to both sides. And this is where transposing, and you could think of, you take negative 5 here and you throw it over on the right hand side, the sign changes. So these two 5s here cancel, and we get x equals 7 plus 5 equals 12. Okay? So the change in subject of the formula, the idea of transposition, it comes from the sequence diagram to give you the reverse sequence diagram. So let me give you one to do, right? So example 2, solve for x the following equation. If you already know how to do this, you don't need to do all that stuff I just showed you. If you already know how to solve these equations, that's fine. But for the people who may have never understood why they did what they did, that's why I introduced you to the idea of a sequence diagram and a reverse sequence diagram. Because often people will be like, well, sir, how you know you're supposed to do, I don't know, add 5 first? How you know you're supposed to add 5? How you know you're supposed to take away 7? People always ask that question. So to answer that question, that's why I give it a step-by-step process here to change the subject of the formula. It always works. Okay. Find a variable you have, which is in this case x. Find the expression that contains the variable x. That's 2x minus 3. Starting with x, do a forward sequence diagram, then do a reverse sequence diagram, then follow the operations in the reverse sequence diagram to change the subject of the formula. Okay. So solve for x in this equation here. Tell me what value you get. I will show you the detailed working after, but you don't have to do the detailed working like how I show you. Whatever method you know, if you already know how to do this, is fine. But there might be some people who may not have ever understood how to change the subject of the formula. And when we start to get into the really hard ones with no numbers, then this step-by-step process would make sense. So I just going through these steps here with you. So we want to make x the subject of the formula, right? That's the first step. What do we need to make the subject of the formula? What is the expression that contains x? This entire left-hand side, okay? So create a forward sequence diagram starting with x and going into the final expression. There's the steps involved. Then reverse the sequence diagram. Reversal of minus 3 is plus 3. Reversal of multiply by 2 is divided by 2. And then write the equation down and apply these steps to both sides. Remember, our equation has to be balanced. Wherever you do to one side, you do to the other side. So starting from the right, the first operation to do is plus 3. So I add 3 on both sides here. You see, I write the first equation in the first line. Second line, I add 3 to both sides. The 3's will cancel to give 2x, and I'll get 12. The next thing to do is divide by 2. So divide by 2, the 2's cancel, and I get x equals 6. Now, you don't have to write all of these things out or even do the sequence diagrams. You could just start doing the working like this. That is the level I'm hoping you all get to, where you could just do the working and see the steps. But for those who are unable to see the steps and not too sure what you need to do first, the sequence diagram is the answer to that, okay? So try, what example is this? This is example 1, example 2. This is example 3 in this section. Under this section, change in subject of the formula, right? So solve for x with this equation here. Could even give you 2 questions for you to try. So for example 3, let me see. I could just skip some steps here. I could say, okay, I'm not sure what to do first. So let me just do a forward sequence diagram, starting with the unknown and ending with the entire expression that contains the unknown, which is the left-hand side expression. Then just reverse the diagram. And then I know to the equation, I need to add 4 to both sides first. And then I need to divide by 3 on both sides. So I add 4 to both sides, I get 3x equals 15. And then I divide by 3, I get x equals 5. Okay. So you don't need to explicitly write out the steps. You could simply just do a quick shorthand diagram to help you out in case you're not sure. Like this might be a tricky one, right? You might be sure about what to do here. So I just do a sequence diagram quickly. I'll add 3 and then multiply by 2. So reverse that, then divide by 2 and subtract 3. So divide by 2 first. I get x plus 3 equals 8, and then subtract 3 on both sides, and I get x is 5. Okay. So you could omit this here. You could omit these 2 diagrams, or you could do it to the side, just in case you're not sure. But the main working is what people are interested in. That's this last block here. All right. So the idea really is to get a little more challenging, right? So one thing we could do before doing a sequence diagram is to put all values on one side of the equation to do transposing, what we call transposition, right? So when you have an equation with the x's on one side of the equation, that's kind of easy. You could just do the sequence diagram if you're not sure what you need to do first here. But when you have x's on both sides of the equation, you need to transpose. And what transpose really means is take a term from one side, put it on the next side. When you do that, the sign changes, okay? So for example, this question here, question 6, example 6, right? This x here on the right-hand side, I will take it and throw it over on the left-hand side. It will become negative x. And then this -1 on the left-hand side, take it and throw it over on the right-hand side. It becomes +1. Okay. So you should transpose things first after expanding. And then when you arrive at an equation, you could just change the subject of the formula fairly simply. Again, when you have to change the subject of the formula and all you have is one expression, you could always do the sequence diagram if you're not sure what you need to do. Okay. So try these different problems here and tell me what values you get. So what I would like to do with the example 5 is just expand it first, okay? Because we have a linear unknown, right? X is the unknown. and is linear because the highest power of x is 1. What we could do, we could just simply expand, okay? So I get 3x minus 9 plus 5 is equal to 2. This is 3x. Now minus 9 plus 5 is what? As minus 4 is equal to 2, right? So now that I arrive at that, if I'm not sure how to change the subject of that formula, I could do a sequence diagram, right? And then a reverse sequence diagram. So I could come here now, and so I need to change the subject of the formula. I need to find for x. So find the expression that contains x, which is the entire left-hand side expression. Put this here. And starting from x, how do I get to 3x minus 4? And then just reverse it, right? Reversal everything. Minus 4 is plus 4. Reversal up, multiply by 3 is divide by 3, okay? And then we could potentially do these steps here in the following order, right? So we write the last equation we had, which is 3x minus 4 equals 2. We add 4 to both sides because that's what the reverse sequence diagram says. So we add 4, 4 is cancelled, we get 3x equals 6. And then we divide by 3. So we get 2. Divide both sides by 3, you get 2. Okay. So that's the answer for that. And again, you don't really need these diagrams unless you're not sure. If you're not sure, you do the diagrams. If you're sure what you're doing, you don't need to write them. You could just continue as one giant question that you're working on. Okay. Here, what I should do with this is you could transpose. So I leave the 2x on the left-hand side. You see this positive x here? It comes over as negative x, right? I move it from the right to the left, so the sign changes. And this negative 1, we'll have the 6 there. This negative 1 goes over on the right-hand side as plus 1. I will end up with x is equal to 7. Okay, so this one's kind of easy. You didn't really need a diagram for that, right? This one here, what we should do is multiply out the brackets on both sides. So we know how to do this, how to expand brackets. This is 2x minus 6 minus 4 equals 3x minus 12 plus 1. Now, what people tend to do is always put the x's on the left hand side. You don't need to do that. You know, you could put the x's on the right hand side if you want. Here I have 3x and I have 2x. 3 is bigger than 2, so I should put all the x's on the right hand side to avoid dealing with negative numbers. So like the negative 12, I'll put it on the, I'll move it from the right hand to the left hand, so it become positive 12. Same thing with the 1. The 1 become negative 1. I already have the 6 and the 4, which are negative there. So I throw the numbers on the left hand side. On the right hand side, I have my 3x already there, but I move across 2x, so it becomes minus 2x. Okay. So now, just work this out. 12 minus 1 is 11. 11 minus 6 is 5. 5 minus 4 is 1. And that's 3x minus 2x is x. So I really didn't even need for these examples to use the sequence diagrams really, right? Transposing helps a lot, okay? So I could probably give you all another one to work out here just for practice. Wait. Okay. So try working out example 8 here. So we could start again. Just really, you really want to expand 3x minus 3 to the 6 plus 7 is equal to, that's 2x plus 4 plus 1. We could simplify the left-hand side and the right-hand side independently, okay? Minus x plus 7, move that around, switch it around. Minus x plus 7 is the same as 7 minus 6, right? Which is 1. And this is 2x plus 5. Now we could transpose the x's to the left-hand side. I could bring across the 2x on the left-hand side, it'll become negative, right? Then I say 5 minus 1, right? I take the plus 1 on the left and put it on the right, it becomes negative. 3x minus 2x is x, 5 minus 1 is 4. Okay. So this is the solution that I got. Now for something a little more ambitious, right? Tell you all this thing gonna get harder, right? So all the stuff we did this week and last week, you're gonna try and do here now. Where you try and solve for this equation, okay? Expanding both sides, collecting like terms together on each side separately, and then you transpose towards the end. Don't try transposing initially, okay? Because you gotta expand these things out. BODMAS, expand both brackets out, take your time. It might have to put square brackets around it to simplify your work. Like you could probably write it like this. Sorry. Right, so you could put like square brackets around it, so that after you expand this out, you would still have a different bracket to help you keep track of things, because you're gonna have some negative signs here and you don't want to get confused, right? So try it like that and tell me what you get. So we want to start expanding this question here, start expanding it out. Okay, let me scroll this to the top here. So if I want to expand this, I write a line over again and just change the inside. So this stuff here is we're not sure what that is yet. And this stuff here we have to expand. We're not sure what this is yet. Okay. So the first one is 4 terms I'm gonna get. Everything in the first bracket must be multiplied by the x. And everything in the first bracket must be multiplied by the +2. Okay, so we go. X by x is x squared. Minus 1 by x is minus x. Right? That's the two things by x. Now the two things need to be multiplied by +2. So x by 2 plus 2x, and minus 1 by 2 is minus 2. Okay, so that's the expansion for that. On the right hand side, I have something similar happening. So you take your time. The first bracket multiplied by x. So I'm getting, just as before, I'll get x squared minus 3x. That's the first two terms multiplied by x. Then the first two terms here multiplied by 1. Then you're just writing it x minus 3. X by 1 is x, and minus 3 by 1 is minus 3. Okay. Now the idea really is to simplify the square brackets first. That's what we want to do. We want to simplify the square brackets. So I rewrite the question again. And inside the square bracket, my next step is to don't try to do too much of things at once. The next step is just simplify the square brackets. So the minus x plus 2x, these are the only two like terms here. This is essentially plus x, right? And here, the only two like terms is minus 3x plus x. So that should be minus 2, minus 2x, basically, right? Then the next line, if you notice it getting shorter and shorter, right? Next line, I'll be able to remove these square brackets now and combine the 5. So let me do that. Let me just take out these square brackets here. So I have all these terms here now. Minus 2 minus 7 is what? Yeah, add in two negative numbers. So this should be negative 9. And on the right hand side here, these two 3's disappear. So I could just not write them, okay? This question is a little bit shorter now. Next line. I could transpose. I could start transposing now. I could move all the x's to the left hand side and all the numbers to the right hand side, okay? Or I could just move everything to the left hand side and put it equal to 0. So this x squared becomes minus x squared. This minus 2x becomes positive 2x. And the minus 9 becomes positive 9. Okay. These two x squareds cancel. And this x plus 2x, we get 3x. So we only get 3x equals 9. Well, x is equal to 3. Yeah, and we're done. So because I saw the x squared being canceled out, I know I'm not going to get a quadratic. So I could put all the x's on one side and all the numbers on the right side. But if I was getting an x squared term in a quadratic term, then the best thing to do is to put everything on the left hand side and put it equal to 0. We'll talk more about that later on in class today, right? But this is essentially how you do a question like this. You all got his answer? Everybody got his answer? So, you know, as I say, it's gonna get harder. Take your time and do this one here. It has a squared term and multiplication of two brackets here. This is the final one you would do that's intermediate. This is still intermediate here. We ain't started to get to the hard stuff yet. But we need to learn some new skills in order to solve the ones that are harder, i.e. the ones with quadratics, okay? Have fun with this. So I did this here to show you all that, say you solve this question and you got the answer 10, right? What you should do is check that your answer correct. So put 10 on the left hand side. That's what I did here. 10 plus 2 is 12. 12 squared is 144 minus 13. That's 114. With the right hand side now. 10 minus 3 is 7 by 10 plus 1, 11. 7 by 11, 77 plus 1, 78. The two sides have different answers. So clearly 10 doesn't make this equation true. right? 10 is not the answer for this, right? And you see that the left hand is not the right hand. So it's very easy to check your answer, okay? What are we gonna do now? We're gonna work this out. So let me expand this a little bit. So I'll put brackets around the squared. And then I'll put brackets around like that, right? So now I'm going to simplify this here. So x plus 2 squared is x plus 2 by x plus 2. Okay. Now is to expand this out. X plus 2 squared is x squared plus 2x plus 2x plus 4. Right? Everything in the first bracket multiplied by x. So x by x is x squared, 2 by x is 2x. Then everything in the first bracket by the second number, plus 2. X by plus 2 is plus 2x, 2 by 2 is 4. The right hand side here now, the x minus 3 by x minus 1. We could do that. This is x squared. Minus 3 by x is minus 3x. Then x by 1 is x. And minus 3 by plus 1 is minus 2. So I'm not trying to do too much of shortcuts here. I'm trying to like show you all the steps. This is 4x here. 2x plus 2x is 4x. These like terms here. And this is minus 2x. Okay. Minus 3 plus 1 is minus 2. And 2 and 2 is 4. We could remove the brackets. And then we could combine the negative 30 and 4. So 4 minus 30 is minus 26. And minus 3 plus 1 is minus 2. I could surely x is over on one side. So let me see. I get x squared minus x squared. 4x plus 2x. And then minus 26 goes to plus 26. Right? So what will I get? I will get the x squares will cancel. 2x plus 4x is 6x. And 26 minus 2 is 24. So x is equal to 4. Right? And then to check your answer, you substitute it, right? 4 plus 2 is 6. 6 squared is 36. 36 minus 30 is 6. So the left hand side is 6. What's the right hand side? 4 minus 3 is 1. 4 plus 1 is 5. 5 by 1 is 5. 5 plus 1 is 6. Both sides are equal to 6, right? So there's the answer here for that one. Hope you all got that. So this is a question from primary school. So I'm reviving things from many years ago for you guys. If I tell you I have two numbers, A and B, and when I multiply them, I get 0. What can you tell me about A and B? Think about it. What could you tell me about A and B?
One of the terms is 0.
One of them is 0, right? Very good. One of them had to be 0. Because if A is not 0 and B is not 0, then you could never get 0 when you multiply them if both of them is not 0. Okay. Question, could both of them be 0?
Yes.
Yeah, right? What if A and B is 0? 0 by 0 is what? 0, right? So what we're supposed to say is at least one of them is 0. Okay, that's the answer. At least one of them is 0. At least being the most important thing, right? Because both of them could be 0. So, okay. What implications does this have for questions like this? If I give you this equation here, x minus 5 by x plus 2 equals 0. What could you tell me about this? I'm multiplying two things, right? A is like x minus 5 and B is like x plus 2. So I basically tell you A by B is 0. And you know, if A by B is 0, then one of them had to be 0. So you say either this is 0 or this is 0. Not so? So you'll say this, either x minus 5 is 0 or x plus 2 is 0. Now, why wouldn't you say, is there a possibility that both of them could be 0? I'm gonna ask you all that in this case. Is it possible that both brackets could be 0 at the same time? Because I'm saying either or, meaning I'm telling you both of them can be 0, but think about it. Is it possible for both of them to be 0, both brackets to be 0 at the same time?
Yes.
Well, what would that mean if both of them are 0 at the same time? If both brackets are 0 at the same time, we could follow this conclusion here. I could say, well, if x minus 5 equals 0, then either x equal 5 or x equal -2. Okay. Is it possible for x to be 5 and -2 at the same time? Does that make sense?
No.
No, right? So you see the problem. That's why I say mathematics how to make sense. Huh? You don't just throw words on a page and say x is this and x is there. You can't say and there. You can't use the word and. You have to use or. And more importantly, in this problem up here, if a by b is 0, we say at least one of them is 0, because the possibility exists that both of them is 0. But a question like this here, where you have one unknown x, and that unknown appears the same place, it appears twice. We can't have and, that don't make sense, right? We can't have both of them being 0 at the same time, because that would imply x has 2 different values at the same time. So we have to say or. And bet we have to say something stronger than or. We have to say either or. Means only one of them could happen, not both. Okay. So this is the general case here where we don't know what A and B is, but this case here, you can't say at least one of them. You have to say only one of them could be 0. You can't have 2 of them being 0, otherwise we have 2 different values for x. I hope that makes sense. So let's look at some quadratics, right? So what was a quadratic? What's a quadratic? Let me get some notes here for this thing. Right? So a quadratic is a polynomial of the form, right? Ax squared plus bx plus c. That's essentially what a quadratic is. The highest power of x is 2. Okay. The coefficient of x squared is not 0, because if the coefficient of x squared is 0, you have a straight line, right? What we call a linear polynomial. Quadratic polynomial, the highest power of x is 2, and the a is not 0. Okay, that's all it really is, right? Some quadratics can be factorized. For example, notion want to spell it like Americans, but so for example, what? So let's take this polynomial from up here. X minus 5, x plus 2. Right? If we expand this out, so let's make up a polynomial. Sorry, let's make up a quadratic. Let me have 2 brackets and multiply them. What will we get? X squared minus 5x plus 2x minus 10, right? That's x squared minus 3x minus 10. And I could put these on different lines. so you wouldn't get confused. Okay. So I'm kind of working backwards here. I came up with 2 brackets, I expand it, and I get a quadratic. How do you go in the reverse direction? How you know if a quadratic could be factorized? First of all, why we factorize in quadratics? That's the first thing. Well, it's because of this. Is this up here? If you manage to factorize a quadratic and it's equal to 0, you could solve it very easily. That's why we factorize. That's why we factorize anything. Factorized expression allows us to solve equations very easily, more easily. That's the only way you could really do it, right? If you watch this equation here, so let me write it like this. What if I give it to you like this now? If I say solve this, right? Solve for x, and I give you this quadratic here. How you know what value x you could use to make this 0? You can start guessing, right? Let me guess 1. 1 squared is 1, 1 minus 3 is minus 2, minus 2 minus 10 is minus 12, that's not 0. So 1 though. Let me try an next one. Let me try 2. Let me try 3. Let me try 4. Guessing is not a good idea. This is not the factored form. This is the expanded form. The expanded form cannot really help you very well. This is one of the most popular forms, which is called the factorized form. If you rewrite this equation as product of 2 brackets equals 0, right? If somebody tell me, well, you know, that's x minus 2 by x, sorry, x minus 5 by x plus 2. You know, I could write it like that. You'll be like, oh, right. So I could just write it as 2 brackets, but the product of 2 brackets equals 0. So then I could come and say all the stuff up here, right? I could say all of this. Let me come back down here now. I could come and paste that there. Ta-da! You know, I'm done, right? If I could take a quadratic and write it, first of all, the quadratic equal to 0, right? They tell me solve for x. Instead of guessing, if I could represent the quadratic as a factorized form, a product of 2 brackets, then if the product of 2 brackets is 0, then one of them had to be 0. So either the x minus 5 is 0, the x plus 2 is 0. So then I could conclude, well, x could be 5 or x could be minus 2, but not both at the same time. Never say and, because x can have 2 different values at the same time. So if I put 5 in here, 5 5s are 25, 3 5s are 15, 25 minus 15 is 10, 10 minus 10 is 0. See, that works as well. And what if x is minus 2? 2 2s are 4, minus 3 plus minus 2 is 6. 4 plus 6 is 10, 10 minus 10 is 0. So minus 2 works as well. Okay? So the aim is, if I have a quadratic equal to 0, my best bet is to see if I could factorize it. If I can factorize, I need more sophisticated techniques. But a lot of times you will get questions where the quadratics could actually factorize. And we kind of need to know how to deal with that, right? That's the next steps. So how to factorize quadratics? Okay, giving you all a step-by-step process here. You have some quadratic here, ax squared plus bx plus c equals 0. A is not 0, right? So step 1, find the product a by c. They will have signs, so be careful. C could be negative, A could be negative. Find factors of AC that sum to B. Okay, so after I multiply A by C to get AC, let's find factors of that that add up to B. Remember, B has a sign as well. B has a sign as well, so be careful. And what we do, if we could find B, if we could represent B as the sum of 2 factors, and those 2 factors give AC, then we could factorize it, okay? The idea is to perform partial factorization of the expression. So let me show you an example here, right? Ask you solve this equation here. Let's see if we can factorize it. A is positive 1, C is minus 10, so AC is negative 10. So we want to find factors on negative 10. What by what is negative 10? I could go 1 by 10, 2 by 5, right? So I could say this is plus 2 and this is negative 5, right? So these are all the possibilities to get negative 10, either plus 1 by negative 10 or negative 1 by plus 10. What are some other factors too? 2 and 5 could work. So negative 2 by plus 5 or plus 2 by negative 5 could work, right? To get negative 10. The idea is when you multiply them, you get negative 10. If you're going to get a negative number, the signs and the two factors are to be different, okay? Now, if I add the two factors, call them F1 and F2, if I add them together, capital F, I could get a number, right? Which one here is equal to B? You say first three not equal to B. B is negative 3. Is the last one is equal to negative 3. So these are the two factors I use in here. So what we want to do is we want to write this expression as, we want to change this B here, this negative 3, into plus 2 negative 5. So I'll put like a brackets around this here, negative 3, right? I could rewrite this. Negative 3x is really 2x minus 5x, right? Positive 2x minus 5x. Let me take out these brackets here. Okay, this is how we rewrite the expression. Negative 3 is really plus 2 minus 5. I hope you all seeing that, right? And then you factorize partially. What does partial factorization look like? You look at the first two terms and see what you have in common. So what is common in the first two terms? X, right? X into what? X plus 2. Okay? I just factorize the first two terms. Now you see this X plus 2 here? I immediately write that here. Okay? And I'm gonna have something in front of it. Remember this from before? Remember this is what we did, right? From before. As soon as I get the X plus 2, I write it here. What do I need in front of this X plus 2 to get minus 5x minus 10? What do I need here in this question mark? I need a sign and a number. What by X is minus 5x? I need a minus and I need a 5. Minus 5x is minus 5x and minus 5 by 2 is minus 10. So I'm done. Okay. And then you factorize again because X plus 2 is common to both these terms here. So we write X plus 2 and we're left with X minus 5 equals 0. And then, you know, we're gonna have all this stuff here, essentially. So if X plus 2 by X minus 5 is 0, either X minus 5 is 0 or X plus 2 is 0. And therefore either X is 5 or 2. That's how we solve it. So it's a little process, right? It's actually not much work when you get to practice it, right? But it is a process that is important. If I cannot find two factors of AC, when added up, I get B, then I can't factorize it, okay? That's essentially the process here. And next class, we'll talk more about this.